My name is Travis Kelly. I'm the Well Construction Program Coordinator with the Oregon Water Resources Department. This is part 2 of my presentation on well construction administrative rules and statutes for water supply wells. In part 2, we're going to continue covering Oregon Administrative Rule OAR 690-210, and then we're going to delve into OAR 690-215 deepening, 220 abandonment, 225 enforcement, and 230 low temp geothermal. If at any time you have questions or concerns as a result of this presentation, feel free to call, text, or email me. Top terminal height. The casing head or pitless unit of any well shall extend a minimum of 12 inches above finished ground surface or pump house floor, and a minimum of 12 inches above the local surface runoff level. The ground surface immediately surrounding the top of the well casing or pitless unit should be graded as to drain surface water away from the well. Without permission of the director, i.e. special standards approval, no casing shall be cut off below land surface except for to install a pitless unit or during permanent abandonment of a well. Liner pipe. Liner pipe installed through caving formations and installed without driving may be of lighter weight than specified by Table 210-2 under OAR 690-210-0190. Such lightweight pipe shall have a wall thickness equal or greater than 0.188 inch. All liner pipe shall be steel in new or light condition, being free of pits or breaks, or shall be of PVC type 1220 or 1120 and SDR 26 class 160 or greater wall thickness. Liner pipe installed in a well shall extend or telescope at least 8 feet into the lower section of the well casing. In the event that more than one string of liner pipe is installed, each string shall extend or telescope at least 8 feet into the adjacent larger diameter liner pipe. Liner pipe shall be removable. Liner pipe may be welded or hooked onto the permanent well casing, but shall not be permanently fixed to the well casing or borehole wall using packers or grout, which prohibit the liner removal. If you do use grout or packers, that liner pipe is then defined as inner casing. And if it is not installed to inner casing standards and or meeting casing specifications, it will be a well construction violation and will result in the well needing to be repaired or permanently abandoned. The takeaways of liner pipe are the 8 feet of telescoping into the casing, the minimum steel wall thickness for liner pipe is 0.188, and that for PVC liner pipe, it has to be PVC type 1220, 1120, and SDR 26 class 160 or greater wall thickness. Cement grout. There are 3 types of cement grout that are allowed. They're Portland cement, high early strength type 3 Portland cement, and high aluminum cement. These types of cement have specific ratios of gallons of water per sack of dry cement, and also have different cure times to when you can resume drilling. At the bottom of this page, it lists the ratios of gallons of water per sack of dry cement. Placement of this cement grout. Cement grout or concrete used as sealing material in a well shall be placed or first upward from the bottom to completely fill the annular space to be grouted, and shall be placed in one continuous operation without significant interruption. If temporary outer surface casing is used in the construction of the well, it shall be withdrawn as the grout or concrete is placed. And then again, when we're looking at how is this grout placed, you need to reference additional appendices to see those types of grout placement. So in Appendix 210-3, it will list in written form how each method of grout placement is to be conducted, and Figure 210-1 gives a visual representation of that. Here's Figure 210-1, and it details the 5 methods of cement grout placement. These figures are very helpful, and it allows you to visualize how that cement grout placement method is achieved. Again, I highly recommend referencing that appendices to ensure that you're aware of minimum borehole diameter relative to nominal casing diameters, as well as additional information that is not explicit in these diagrams. I am going to read method A from that appendices, and you can compare that to how this figure describes that same seal placement method. Method A, the well bore shall be plugged with a drillable plug or bridge at the lowest point to be sealed. A well casing with a float shoe at its lower end shall be placed in the well and suspended slightly above the point of bearing. A grout pipe shall be run inside the casing to the check valve. The grout pipe shall be connected to a suitable pump, and water or drilling fluid shall be circulated to clear the annular space. Grout shall be pumped through the grout pipe until clean grout completely fills the interval to be sealed. The grout pipe shall then be removed and cement allowed to set. And then it references again figure 210-1. So for each one of these methods, the preceding appendix describes these methods and gives additional stipulations to these seal methods. In line with our discussion of cement grout placement, there is also a minimum time of waiting prior to resuming construction after grout placement. In all instances, the shortest time to resume construction after grout placement is 6 hours. So the time needed for final set of cement grout mixtures varies greatly in accordance with cement water ratio and temperature. When cement grout is used to seal a well, construction should not resume until after the final set of cement grout mixture. Performance of all cement grout seals shall be the responsibility of the person responsible for the construction of the well. Under no circumstance shall construction resume within 6 hours of placement of the cement grout seal. Recommend periods of the time for a final set are, if using Portland cement, 72 hours. If using high strength early type 3 Portland cement, 48 hours. If using high aluminum cement, it is 6 hours. A well test is required upon completion for every well and must test for yield and a drawdown, either by baling, pumping, or air testing for a period of not less than 1 hour. Any testing method that does not provide for drawdown measurements during testing is not an accurate, reliable test of yield. So that being said, most people who operate air rotary equipment are not going to be able to accurately record their drawdown. And so that brings up that statement I just said, that any testing method that does not provide for drawdown measurements during testing is not an accurate or reliable test of yield. So the water that is returned to the surface through an air test, because of how it evacuates majority of that water via air, is very hard to document drawdown, or it will document all the water was evacuated from the well. So again, we're getting a distorted view of yield and is not an accurate representation of that well's yield over time. Again, when we're looking at the requirements of the well test, yield and drawdown are those requirements, and that is the emphasis of this slide. Prior to or after being placed in the well, pumping equipment, sand, gravel, and well casing shall be thoroughly hosed or sluiced with water and shall be disinfected with a solution containing at least 50 parts per million chlorine. All water introduced into the well during construction shall be clean and potable. Upon completion, the well and its equipment, including the interior of the well casing, shall thoroughly be swabbed and cleaned to remove all of the oil, grease, and foreign substances. The well and its equipment shall be disinfected by thoroughly agitating and mixing in the well a solution containing enough chlorine to leave a residual of 25 parts per million throughout the well after a period of 24 hours. Disinfection should also occur following the installation of pumping equipment. So again, when we talk about disinfection of wells, the applicable OAR is 692.10.0380. Appendix 2 details the disinfection of wells, and you need to use either laundry bleach or high test hyperchlorite compounds. The quantity of hyperchlorite needed to provide 50 parts per million active chlorine in a well is represented in these three equations shown here. On the left, you see the two types of approved sources of chlorine: chlorine bleach laundry detergent or hyperchlorite tablets at the bottom. And then you see the equations for determining the number of pints needed, the ounces needed of that, or the number of tablets. Again, when we're looking at this, you can readily determine how much water is in the well in feet, and then you can figure out the gallons of water per foot based on the nominal borehole or casing diameter. This appendix, table 210-3, details the gallons of water per linear foot on various nominal diameters of casing or boreholes. You can see in a 6-inch well that it's roughly 1.5 gallons per foot. OAR 690-215 governs the maintenance, repair, and deepening of wells. And so when we look at a well after it's constructed and is on a property, that well is the property owner's liability to maintain in the as-built construction after the well driller leaves. So that's really where it goes into liability after the well constructor leaves, for maintaining that well in its as-built situation, setting, etc., maintaining setbacks, ensuring the wellhead's protected, all of those things. Because the owner is liable for that maintenance, it does not resolve the driller's liability of ensuring the well is constructed to minimum standards. So then we talk about deepening of a well. Only certain wells can be deepened, and the requirements of that play out in that only the following wells may be deepened without approved special standards: wells with an original well report that describes the construction, and that construction must meet minimum standards. And if that is the case, then that well report has to be referenced on the deepening well report. Conversely, if the original well report does not detail this well meets minimum construction standards, that well can be deepened if that well is recased and resealed to meet current minimum construction standards during the deepening. Additionally, wells can be deepened that don't meet these standards through a special standards process, though the approval of that will be highly unlikely without having an original well report or being able to reconstruct the well to minimum standards. If you are being contracted to deepen a well, I highly recommend reaching out to your local well inspector to review the original well report to ensure that meets minimum standards and the well is okay to be deepened without any additional approvals. Well abandonment is governed through OAR 690-220. Any water supply well that is to be permanently abandoned shall be completely filled in such a manner that vertical movement of water within the well bore, including vertical movement of water within the annular space surrounding the well casing, is effectively and permanently prevented. So to that note, anytime a well replacement is going in for an existing well that doesn't meet applicable setbacks, that existing well is required to be permanently abandoned within 1 year after a replacement well is completed. This situation is oftentimes much better dealt with when you are on site drilling that new well than telling the landowner this information. And if there is a situation like this, please reach out to your local well inspector so that we can become aware of this non-compliant existing well and work with the landowner to get it permanently abandoned to help protect the resource. Continuing on the well abandonment, for drilled wells, there are two types of abandonments. There are cased wells and uncased wells. In the situation of a cased well, if all or a portion of the water supply well casing or liner pipe is not removed during the abandonment of a well, the remaining casing or liner shall be thoroughly ripped or perforated. The number and size of perforations may vary, however, the perforations must be sufficient enough to allow grout to migrate outside the casing and effectively prevent the vertical movement of water. The annular space between the casing or liner and the drill hole wall shall be effectively and completely filled with cement grout applied under pressure. Perforations are not required in the sealed interval, provided proof of the original seal can be verified with the original well report. The verified seal interval shall be filled with cement grout, concrete, or unhydrated bentonite. Uncased portions of a case well shall be abandoned and filled in accordance with these rules. So again, when we look at this, the emphasis here is that to abandon a cased well, the casing must be perforated and the borehole and well filled from the bottom up with cement. Conversely, if you want to use bentonite to abandon a cased well, the casing must be pulled prior to bentonite placement. And if you are going to use bentonite for well abandonment, advance notice is required to the local well inspector prior to its use. Continuing down the road of abandonments, there are special caveats for the abandonment of gravel and filter packed wells. This is described in OAR 690-220-0090. So gravel pack or filter pack abandonments must receive written approval, i.e. special standards from the department prior to beginning work. Any method of abandonment proposed must ensure that all perforated sections of the casing will be pressure grouted throughout and that the remainder of the well is filled with cement grout. As you can see in these diagrams of filter pack or gravel packed wells, the intent here is to ensure that that grout applied under pressure is able to effectively migrate out into the filter gravel pack and effectively prevent vertical movement of water in that screened interval. Dug well abandonments. The takeaway on this one is that as a well driller, you must have an approved plan prior to doing this abandonment. That plan can be approved by the regional well inspector and is not a special standards approval, but you have to have written or verbal approval from a department representative of your abandonment plan. This request for or detailing of your plans must include the location of the well, the name of the landowner, well diameter, well depth, depth to water, and type of well casing or liner material, if any, as well as the proposed method of abandonment. A method to be used in the abandonment will be approved by the department if the method will adequately protect the groundwater resource. And then to do well abandonments, obviously a licensed bonded well driller is allowed to do dug well abandonments as long as they file a start card and get department approval of their abandonment plan. Dug wells can also be abandoned by landowners with a landowner permanent bond to abandon a well, and they can also be abandoned by a landowner in the presence of a department representative. We greatly appreciate anytime you find a dug well that you notify the regional inspector because of the huge danger that these wells pose to the health and safety of people and animals on the surface, as well as the viable conduit of contamination into the groundwater. We're going to just briefly touch on enforcement as described in OAR 690-225. On the left, you will see a list of minor violations. If it's not listed as a minor violation, it's considered a major violation and a higher possible civil penalty. And on the right, you see the process of an enforcement. And so our Oregon administrative rules and Oregon revised statutes create a line in the sand. And if your intent is to follow rules and stay behind that line, we're going to be as flexible as possible to help ensure you construct wells to meet standards. Conversely, if you intentionally cross that line and your intent is to not follow rules, it will result in enforcement. And you can see that in that flow chart, where again, at all possible times, we're trying to work with the well drilling community to resolve issues as fast as and as cost effective as possible. And the real consequences of that goes into enforcement, and it takes a huge amount of department staff time and results in a formal enforcement that can result in civil penalties and or license suspension, and in worst case scenarios, loss of license and loss of your bond. So again, when we look at our enforcement process, it's really how you choose to interact with the agency. So the real takeaway of this slide is work with your regional well inspector, work with the department, ask questions, and contact us at any time you're uncomfortable or concerned about a potential situation. And we're going to do our best to work with you and come up with a manner to resolve the issue that doesn't result in enforcement. OAR 69230 describes the process for low temp geothermal wells. All low temp geothermal fluids are part of the groundwater resource of the state of Oregon and shall be administered by the Water Resource Commission. The commission recognizes that these fluids are developed primarily because of their thermal characteristics and that special management is necessary. So what is the definition of low temperature geothermal production well? It means any well where the bottom hole temperature is less than 250 degrees Fahrenheit that is constructed or used for the thermal characteristics of fluid contained within. So we, in these diagrams here, we see the two common types of geothermal systems. On the right, we have the closed loop system. And then on the left, we have the open loop system where you have a supply well and a return injection well. If you're working on a system on the left, an open loop system with an injection well, the main things to understand is that that injection well, to receive water being injected back into the aquifer, needs to have and be registered with the Department of Environmental Quality, DEQ, through the underground injection control permit process. Additionally, the Water Resource Department has to approve that well for injection. And then another caveat to be aware of this is that any use that exceeds those exemptions of 15,000 gallons a day for domestic purposes or 5,000 gallons a day for commercial purposes in an open loop system will require a water right for that additional use. So again, the main takeaway here is that all of this is low temperature geothermal if the water temperature is less than 250 degrees Fahrenheit. Thank you so much for your time. Here's my contact information. Feel free to reach out to me via phone, text, or email anytime, and have a great day.